Hi, I'm David Gillespie from the Global Startup Program at AWS. I'm here today with Brian, co-founder and CRO of Arcee. Brian, welcome.
Thank you, David. Great to be here.
We appreciate your time coming in, and we're excited to hear about Arcee. It's a fun name. Where does that come from?
Sure. David, do you remember the old Transformer movies from back in the 90s?
I do.
So the female Transformer, her name was Arcee. And so me and one of my co-founders were both girl dads. So we named the company Arcee after that, which is why if you go to our website, you see all the pink going on.
That's so great. What a fun story behind the name.
Yeah, well, I mean, we are building large language models, small language models, which are transformer models. So transformer is just a little bit of a play on the words there.
Got it.
Yeah.
That's cool.
Yeah.
So why don't you tell us a little bit about the company?
Sure. So Arcee is a small language model company. We build and deploy and train small language models for all different types of companies.
Right, a small language company. I feel like that is flying against some of what we've learned about this space. So tell us a little bit more about what it means to be a small language company.
Sure. So many companies today are looking for domain-specific models. They want to use their data. Large language models today are just way too general to actually capture very specific tasks that which companies are trying to achieve. So for example, if I'm trying to do something with claims processing as an insurance company, there's no need for me to have poetry or rap music in my model. It's not going to actually help. So what Arcee does is we actually build models specific to the companies with their data so that they can have very specific answers to questions that really are relevant to their use cases.
Right, and are you starting with a large language model, then augmenting that? Is it a model of your own? Tell us a little bit more about what's underneath.
Sure, yeah, it's a great question. So what we do is we use an open source model, and then we merge that model with the data of the company. This is called a model merging technique. We've invented this model merging technique. It is utilized within all of our clients. It's a very common technique. If you actually look on different leaderboards of models and performance, you'll see a lot of model merging happening today. So this technique allows for pretty much the best of both worlds. You have the injection of knowledge from the data from the company, as well as you have continuous pre-training that's happening with the actual open source model, bringing it together to have a very high performant model.
So that's on the surface level, right? The experience your customers are having. Tell us a little bit more about what's going on behind the scenes and how you're leveraging AWS to build what you're building.
Yeah, absolutely. So our entire platform is built on AWS. So we actually build and deploy these models within the VPC of AWS. So our clients are actually owning these models that actually are deployed and working specifically on all AWS hardware and components. So many of our clients are utilizing pretty much all of the components under the hood of AWS to build that model, to deploy that model, to utilize. And so we've made that obviously conscious decision to work with AWS, just given the track record, the amount of great innovation that's coming from AWS in generative AI. And so yeah, we're super excited to work with AWS on all of our client needs.
I'd love to press deeper on that use of AWS. You know, this is a space that we were talking before we came on camera that AI was constantly 10 years away. You know, it's just 10 years down the road.
Right.
And then suddenly it was here.
Yep.
Right? And we've seen a ton of innovation across the industry over the last, call it 2.5 years, that seemingly came out of nowhere, but we know has been building for a long time. There are so many different places that a company like Arcee could be building. Can you talk a little bit more about what specifically drew you to AWS and why you're building there?
Yeah, I mean, I'd probably say one, it's just the overall network of suite of products that they have. So when I think about the chips right now with Trainium and Inferentia, that is a huge advantage for our clients because again, what we are building is the most cost-effective models for companies. And companies right now are very concerned with just the overall costs that are happening out there in the market. And so when you think of what they're trying to do is they're innovating by bringing these new language models into products of their own. And by doing so, they want to try to keep their ROI extremely tight. So they're actually doing a lot of just changes and a lot of different innovations. So when I think about AWS and the product suite that they have, whether it's OpenSearch for the vector database or whether it's Trainium and Inferentia on the chip side, this is giving our clients an extreme advantage because they are able to really build a very cost-effective model that's very domain-specific and not break the bank on costs for doing this. And that's going to enable them to then build more small language models for different departments within their organization. So we think AWS is just well positioned for our suite of solutions.
Let's go a little bit deeper on ROI. 2023 was the year of optimism, experimentation, the art of the possible. 2024 seems to be more about, okay, how is this going to deliver value for the business? So can you talk a little bit more about what you're specifically doing, one, that sets you apart from your competitors, and two, that you're doing with AWS that means your customers can get to that ROI faster?
Cost optimization is about the year of 2024, in my opinion. A lot of companies have seen the promised lands of AI, but then they've also seen what that bill might be. And one of the biggest things that we help optimize for with our clients is really around the chips and what they can do with compute. And that's where AWS gives us a huge advantage in market. The fact that you have inferential and Trainium chips that run at a drastically reduced cost. And when you think about these companies working on all these different small language models, they want cost optimization, and then secondly, they want ownership. With AWS, you get both. You get the most cost optimized compute, and then with our models on small language models, you get the ownership of having that model in your AWS cloud for all time.
Pressing a little bit further on that small language model versus the large language model, and again, we hear mostly about that large language model. I imagine when you get to talking to customers, they are looking for, at least initially, something that can be that be-all, end-all kind of model. Your proposition is that bigger isn't necessarily better. Can you talk a little bit more about that?
Sure. So small language models are really made to solve very specific problems. And when you think about a large organization and you think about one model that can rule them all, we're just not there yet, not even close. And why we think domain-specific models are much better is we look at the answers in which they're giving. The data of these companies is so vast, so extensive, and they don't want to take that data and put it into a large language model system. They want to own that. That ownership is very key. And to own that, you need to build your own. And we, with AWS, give you the power to do that for any task within the organization. So you might conceivably look at the size of the model being small, but it's more about the accuracy. So I look at large language models as being probably a 1,000 feet wide but only an inch deep, whereas we are just an inch wide but we're 1,000 foot deep. And that depth in that answer is really what gives these companies the power to make decisions faster.
Are there ways of scoring that you use? You hear a lot about, oh, this new model performs 2.5% better than the one that came before it, which is meaningful from a data science point of view, but probably not that meaningful from the end user experience.
Right.
How do you address that same sort of question?
Yeah, I mean, benchmarks are definitely very valuable, but I think always having the human in the loop to actually go and conceive what the answers really are. When you look at small language models, they do perform better on a lot of those different benchmarks, a lot of the times just given the specificity of what they actually are putting out from the different domains. You're starting to see more small language models today coming out from a lot of the big open source players today. They're building 7 billion parameter models as well as 70 billion parameter models aside of those, and now doing them very specific in financial services and healthcare and all of these different industries because they know there's different nomenclature, there's different language, there's different nuances that you have to really have to have a very performant model for these different verticals.
And then tying that back to the customer experience, you talked a lot about that combining of the open source model with the company's first party data. I imagine a number of companies will say, oh, we just don't feel like we've got that data. Is it the case that companies have more data than they realize, or you help them build that in some way? What's your process there?
Sure, good question. Two things. One, you don't need as much data as you think to build a model. Now, the components of what we do is taking an open source model, which already is a 7 billion parameter model, and utilizing that data set. That data set can literally be only hundreds of thousands of actual data points versus millions or billions of data points, because again, you're merging that data with the open source model.
And go a little bit deeper on data points, because that, to the uninitiated, could be any number of things. So what constitutes a data point, and what is that that kind of archive that maybe companies are sitting on that they don't realize?
Yeah, tokens is kind of the nomenclature of how we look at that. Tokens are a composite of number of words per page, and that's how models are built. So when you see, oh, how many tokens are actually being put through on a model, it's really using tokens as a mechanism to drive how much data. So literally you don't really need I'd say millions of documents to actually build models. You really don't need as much as people really think. And the other side is true. Synthetic data is becoming much more valuable today for small language models. Generating synthetic data that's very similar and looks very much like real data is becoming more and more prevalent. There's a lot of companies now that are just putting out data sets of synthetic data to actually inject into models. So there's plenty of places now to get data to make that make that happen for small language models. So we see that continuing on.
I want to go one step deeper on tokens. So
Sure.
let's break it down really simply. If I'm one of those companies, maybe I've got a support email. Is a token that email, or are there several tokens in there? The product a person was using, when they were using it, when they bought it, those sorts of things. Like, how much data is there in one piece of communication?
Sure. So a token is actually a number of words within a document. So it's even smaller than that. So when you think of like tokens and you hear, oh, I have 1 billion tokens, that pretty much means I have a couple 100,000 documents or words within documents. So yeah, it's a crazy data point, but it really is. That's just the normalized, standardized way of actually computing and figuring out how much data is being put in these models. Yeah.
Synthetic data, that's something that's been coming up a lot more recently, but perhaps people don't really understand what that is. Can you talk a little bit about what that means to you and how you deploy it?
Sure. So sometimes there's small samples of data that isn't enough to actually build a model. So think of using large language models as a way to generate more data for an actual other model. It's kind of like an inception thing when you think about it. So with any type of company like Arcee, we can actually contextually generate more data with a small data set. So we'll take a small data set, we actually run that and model that data to actually produce more data. That data is not real data, it's synthetically generated. It was generated from a machine, i.e. a model, to then be utilized for inside another model, if that makes sense.
Sure. We've also heard a lot about how models can hallucinate. Are there then concerns about hallucinations in that synthetic data, or do you how do you address that?
Yeah, I mean, you have to benchmark it to make sure that the data that's coming out is performant to the task in which you're trying to achieve. So there is definitely different benchmarking and ways in which you make sure that your synthetic data is actually applying to the right type of use case or the right type of data that you're trying to. But a lot of times what we have seen, just like with the models over the years that are getting better and better, synthetic data is also conceivably getting better and better, which is great because everyone needs more data today to increase the power of their models.
There's the old adage in technology that the best way to predict the future is to invent it. So what is that future that you're predicting and building towards?
Sure. Well, I don't think artificial general intelligence is going to take over the world, commonly now known as AGI. I see a world where small language models exist for every person. So everyone will have their own personal assistant of their own data, being able to ask questions, given the fact that they can then do any different task and everything based on what their own persons need. So I see that as the world. A self-fulfilling prophecy, given I work in small language models, but this is the way I think it's going to progress versus the one model to rule them all.
Well, you've made me a believer today.
All right.
Brian, this has been fascinating. I know you're very busy. Thank you for taking the time to spend with us today at AWS.
I really appreciate it, David. Appreciate the partnership at AWS and having us today.